Okay, so today we're going to be looking at graphing rational functions, but all cases where we have all three cases of the horizontal asymptotes, including slants, and if a rational function has a hole in the graph as well. Okay, so we're going to be putting it all together. So if you look at the other videos on each individual one, this is basically all of them together. So the first thing you do when we look at a rational function like this is we basically look to see what we have going on in our polynomial on top and polynomial on the bottom. Now, I have it in factored form already. If it wasn't in factored form, I'd have to completely factor the numerator and the denominator to get to this point. So as I'm looking at my factors here, I notice the first thing is that I have a common factor in the numerator and the denominator. So that right there is telling me that I definitely have a hole in my graph. If not, when you would have started putting down this information, you would have had an x-intercept at -2 and a vertical asymptote at -2. And again, you can't have an x-intercept on a vertical asymptote. But when we remove these factors, we are removing this discontinuity and it creates a hole in my graph. So my hole is at -2 because that's the solution of whatever I removed. So what I have left is 2x, x plus 1 over x minus 2. Now this is what I'm going to use to find my information. So my x-intercepts, I have 0 and -1. Since I have an x-intercept of 0, 0, so is my y-intercept, so I got that. My vertical asymptote, I've got one of them at +2. And then when I go to do my horizontal asymptote, I notice that I have the power on top being bigger, which means I have a slant in this one. So when I'm distributing my 2x, I'm going to get 2x squared plus 2x over x minus 2. And that's what I'm going to use to do my long division to find my slant. So I'm going to come over here and put x minus 2 and 2x squared plus 2x under the radical. Sorry, under the division. Then we're going to say, okay, what times x gives me 2x squared? And that's 2x. So you get 2x squared minus 4x. Subtract, which changes the signs. And then you have 0 here. And then 6x plus 0. What times x gives me 6x? That's positive 6. And I can stop because now this right here is my slant asymptote. So this is a slant at y equals 2x plus 6. Okay, so I've got all of my information, and now I'm going to graph everything. So I'm going to put all my information. My vertical asymptote is at +2, which is right here. I don't have a horizontal, I have the slant, so I'm going to use slope-intercept form. So my slope is 2, my y-intercept 6, so up 2 over 1, up 2 over 1, up 2 over 1, so like that, down 2 over 1. So there we go. Now put in my x-intercepts. I have one at 0 and at -1. And then my hole, which is at -2, we got to figure out where that hole is going to be. Okay, so we're going to plug in -2 into my function. So we get -4 times, so -2 plus 1 is -1 over -2 minus 2. So -4 times 1, -1 is +4, and that's -4, so it's at -1. So my hole is at -2, -1, which means my hole is right there. Okay. Now, we got everything graphed, so let's look at what we got. So we have a slant asymptote here. I know that these 3 points have to connect, and I know these x-intercepts cross, So it starts here at my hole, comes up, crosses through, crosses back down, follows that side, and this side will follow my slant that way. Okay, if I didn't have this hole there, I would have had to figure out, plug in a point and see if it was in fact this way or if it was going through the other way. Okay, now the other side, the right side, doesn't have a x-intercept, which means that it has to be up here. And again, I'll put my, it goes kind of off the graph, so the top piece is going to look like that. And that's our function. So I have, in this one, I have a slant and a hole. Okay, so we can have both. We can have a bunch of holes. Okay, all right, so let's look at the next problem. So again, let's look. I have it in factored form, so it's really easy. Do I have any common factors? It almost looks like I have a common factor, but that's +2 and that's -2, so I don't have a hole, so I don't have to worry about a hole. The bottom's bigger, so I don't even have a slant. So this is just a regular, good old-fashioned rational equation. So my x-intercepts are at, from the top, +7 and -2. I've got 3 on the bottom, so I have 3 vertical asymptotes, one at -5, one at 2, one at 8. Horizontal, the bottom is 1 bigger, so the bigger bottom tells me I'm automatically at 0. And then f of 0 to find my y-intercept, it's going to be -7 times 2 over 5 times -2 times -8. So 2 and 2, so these are 1. So I end up with a negative times a negative, which is positive on the bottom. So I end up with -7 on top and 5 times 8, which is 40 on bottom. So my y-intercept is at 0, -7 over 40. Okay. All right. So here we go. Vertical asymptotes. I got 3. So I have one at -5, one at +2, one at +8. My horizontal is at 0. My x-intercepts are at -2 and +7. My y-intercept is at 0, -7 over 40, which is basically somewhere between 0 and -1. And so here we go. Now, on my left side and my right side, I have no x-intercepts and my horizontal asymptote is at 0, which means on both sides it's either above the x-axis, all of it, or below the x-axis. So the only way I'm going to be able to tell that is if I plug in points. So the first point I'm going to plug in is -10. And again, at this point, I just care if it's positive or negative. We're on the positive side or the negative side. So when I plug a negative into my first factor, I get a negative on top. The second one is negative. Then negative, negative, negative. So negatives divided by negatives turn positive, but I net negative. So I know that I am down here. And let's do the positive side. So when I plug in +10, I get positive, positive on top, positive, positive, positive on the bottom. So on the right side, I'm on the positive side, like that. Now let's start with the middle. Well, in between -5 and 2, I have 2 points. I have a y-intercept and I have an x-intercept. So that tells me, since it has to cross, it looks something like that. Now on the other middle section, I have an x-intercept, but I don't have another point. So I don't know how this necessarily crosses. So I have to use another point. So I'm going to use x equals 4. When I plug x into the 4 in the top, first one's going to be negative, second one is positive. On the bottom, first one is positive, second one's positive, third one's negative. So negative divided by negative, so net's positive at 4. So on this side at 4. And now that I have 2, I know it goes like this and like that. And that is graphing rational functions with all of the cases in it.